Alright, today we're going to learn about the MVT and how to apply it. Anybody know what MVT stands for?
Numerical value. Numerical? You said
Something value theorem.
Something value theorem is correct. What's the other value theorem that we know?
Intermediate
value theorem.
Median.
Close.
Median.
What's another word for average?
Mean.
So this is the mean value theorem. We're looking at the mean value theorem. Okay, before we get into mean value theorem, we need to talk about two other things.
We have to do the therefore thing on this too.
Do what?
Therefore, by the MVT.
Maybe. It depends on how the question's asked. Alright, IROC is what we're going to call this. Anybody know what IROC stands for? What was something we dealt with yesterday that started with an I?
I just got really child abuse or something. Instantaneous.
There we go, instantaneous. Okay, so the first word is instantaneous.
Rate of change.
Rate of change, very good. So IROC stands for instantaneous rate of change. How do you find IROC?
I said numbers thingamabob.
We need the derivative. You plug into the derivative to get the instantaneous rate of change. Because where does the instantaneous rate of change happen? At a specific spot. Okay? So instantaneous rate of change happens at a specific spot. Okay? What else did we talk about yesterday? Average rates of change. So what are we going to call that? AROC. Okay? How do we find AROC?
By finding the average between the 2 points.
Okay, we need two different points. We need an interval. Okay, we need an interval to find the average rate of change. Again, where does IROC happen? At one specific location. AROC happens over an interval. Okay. All right. So, if I have my function, let's call it x. How am I going to represent IROC? F prime. Okay, and we'll call it C. We'll call that location C. So IROC is going to be F prime of C. AROC. How am I going to find AROC? It's not F of C because what? No. Now go back. You guys aren't listening to what you're saying.
Prime of C minus something over C. That thing?
No, you're close.
F of C minus F of C, like
you're close. Right. What do we say we need in order to do AROC?
3 points.
We need an interval. Okay, so let's call our interval. Let's call our interval A to B. Okay. Yes.
So it would be F prime of B minus F prime of A over B minus A.
Okay. Now let me write it down, and then I want you guys to think about it. I want you to think about what everything represents here. What does F prime of B represent?
Does your represent?
Where? All right. So this represents the instantaneous rate of change at B. What does this represent? Instantaneous rate of change at A over the change in the interval. Is that what I want for average rate of change? No, that's not what I want. Okay, what is it I want? There we go. I want F of B minus F of A. Okay, and let's use some units to talk about Y. All right, so let's say my units for F were meters. Okay, so let's say my units for F are meters, and let's say the independent variable is seconds. Okay, so what would my units be for F prime of C? Meters per second. Okay, and then here we need to talk about the units for the top and the units for the bottom. If I'm doing F of B minus F of A, what are my units going to be for the top? I'm just dealing with F. What are my units for F? Meters. Okay, and then what is the B minus A dealing with?
Meters.
Seconds. Okay, the units for AROC and the units for IROC need to be what? The same. Do I have the same units? Yes. Now, if I did the F primes in here, what would my units be for the top? Meters per second. So I would have meters per second over seconds, which does not match my units here. Okay? So if you get confused on what AROC is, figure out what the units for IROC are, and then understand that my units for AROC need to match that. Okay? And again, that reiterates, what do I always say? Units are your best friend.
How do they match? Like, how do meters per second match?
There's meters per second and meters per second.
Oh, so you're looking at that, if that matches that prime.
I'm looking at, I want my units of IROC and my units of AROC to match. Okay? Now, MVT. MVT says that if I have an interval, some point on that interval, what do you think needs to be true about these two things?
They're equal.
They have to be the same. That's what MVT says. Okay, but there are some requirements, just like on IVT. Anybody remember what the requirements were for IVT? We must be continuous on the closed interval. There are some requirements for the MVT. There are two requirements. It's got the first requirement the same as IVT. What was that requirement?
Must be
Continuous. So we need to be continuous. Okay, we need to be continuous on our closed interval. Continuous on our closed interval. And then what's the thing you think we need to add since we're dealing with MVT? Has to be differentiable. Okay, what brings differentiable into the play here? What did we do that brings differentiability into play? We took the derivative. Okay, so we did the derivative with IROC. So that's where differentiability comes into play. On differentiability, we want the open interval. So we need to be continuous on the closed and differentiable on the open. If I have those two things, then I'm guaranteed that the MVT has to work. Okay? Now, let's back up. And you're going to have to back up a long ways from the fall semester. What's something that right there represents? Slope of the tangent line. Perfect. So this represents the slope of the tangent line. What does that represent? Slope of what? Secant line. Slope of the secant line. Okay? So, what does the MVT guarantee? That these two things have to be equal, which means that the slope of a tangent line and the slope of the secant line have to match up somewhere between A and B. Okay? So the next thing we want to do is use this graph to draw some secant lines and then see how the tangent lines match up. We're getting ready to draw it. Okay? So, let's say we are going from, our interval is -1 to 2. Okay? Let's say we're doing -1 to 2. Alright? So if I'm going to use MVT, what's the first thing I need to ask myself? Is it continuous first? Because in order to be differentiable, what do I first have to be? I first have to be continuous. So is this thing continuous between -1 and 2? Yes. Because what do I not have? No holes, no asymptotes, no cusp are fine on continuity. No piecewise, no jumps. Okay, so we're good to go. We talk about differentiability, that's where the cusp comes in. There's no cusp, so we're good to go there. Okay, what are some other things that cause differentiability issues when you're looking at a graph besides cusp? Vertical what? Tangent line, vertical tangent line. Okay, and the other thing was continuity, but we already talked about that. All right, so we're interested in this, and then right there. All right, so those are my endpoints. So if I want to find AROC, again, what do we say AROC represents? Average rate of change, what else does it represent? Slope of the secant line. If I want to find the secant line, the slope of the secant line, what am I going to do with those 2 points? I'm going to plug them into my formula. Visually, what am I going to do? I'm going to draw my secant line, which means what am I going to do with those 2 points? Connect them is what I'm looking for, yes. You guys are thinking too hard. Okay, so there's my secant line. Whenever I connect my endpoints, I'm drawing my secant line. Okay, so there's my secant line. Now, the MVT guarantees that what has to happen between -1 and 2? I have to have a tangent line that has what? That same slope. Okay, can you see anywhere up there where I'm going to have a tangent line that's going to have the same slope? And does anybody want to come up and draw? Anybody want to come up and draw? There's 2 of them. Come up and draw one of them. Come on, Hunter. And let's give you a different color.
You're right.
Wouldn't there be one like? Oh, maybe that's a little bit off, but around this area.
It's a little bit off, but you're pretty close. I like it. All right, somebody come up and get the other one. All right, Ethan. Just all that has to happen is you have to draw it to where it touches between in that interval.
This is like right there.
Very good.
Okay.
Okay, so we've got 2 locations. We've got a value here, and we've got a value here. Where what happens? What happens at those 2 spots? The what? Slope of the secant line and the slope of the tangent line are the same. Okay. Now, what does the slope of the tangent line represent again? What do we call it? What's the acronym? IROC. And what's the slope of the secant line called? AROC. Okay, so we found spots in here where the IROC is equal to the AROC. Okay, that's what it is. That's the MVT. So if I'm continuous and I'm differentiable between 2 of my input values, then somewhere in there I have to have at least one spot where my instantaneous rate of change is the same as my average rate of change. Yes?
I want to try to get it straight. The blue line represents your AROC.
Blue line is my AROC.
So the secant line represents your, okay. And then the tangent lines represent your IROC.
Correct. Okay. So the slope of this line is my AROC. The slope of these lines are my IROC. And all 3 things match up. All 3 things are the same.
It's the same.
Say it
How
again?
do you know the slope is the same?
What do you mean?
Just by looking at it. How do you know the slope is the same? Is it just like an eye test? Or?
Just visually. Just visually, you know, if I'm drawing my tangent line is going to curve. And eventually my curve is going to match up with that line. Okay. And then I follow it here. Eventually I'm going to match that line. So you're just visually drawing. If there was a tangent line right here, it would look like this. If there was a tangent line there, it would look like this. So I'm looking until I get a tangent line that looks like that one. Okay. All right, everybody good with that? All right, so let's do... All right, we're going to do a practical application of this thing. All right, so we're going to talk about position. Okay. So what are 2 variables we use to talk about a position function? S of t and x of t. All right, so let's do x of t. Okay, so let's say this is a position function. Okay, and let's say the dependent units are miles and the independent units are hours. So where does miles go and where does hours go?
Wait, which one's which again?
Miles is dependent and hours is independent.
Miles is on
Miles on the bottom.
Miles up here. This is always your dependent, and your independent is down there. Okay, so I'm going to say 3. I'm going to say this is 210 right here, and I'm going to say this is 3 hours right here, and we're going to meet right there. All right. So there's my position graph. So the first thing I want to ask you is, what is my average rate of change? Or how do I find my average rate of change?
You draw the.
All right, let's connect the dots. Connect the dots. So if I connect the dots, there's that. Okay, but let's actually find our slope this time. Okay, we've got some numbers to deal with. We can actually find the slope. So what's my slope? Let's get ordered pairs, and maybe that'll help you. What's my ordered pair right here?
0, 0.
0, 0 is right here. Ordered pair here. 3 and 210. All right. So what do I have?
You can do the distance from the line.
No, I want the slope of that thing. Right. So give me that to me.
0.
Let's do 210 minus 0 over 3 minus 0. So this ends up giving me 70. Now, what are the units for that?
Miles per hour.
Miles per hour. Okay, so that is what? It's a slope, but it is also AROC. Now, so let's say you're driving somewhere that was 210 miles away, and it took you 3 hours to get there, and then I tell you that I never drove higher than 65 miles an hour. Would I be lying, or could I be telling the truth?
You'd be lying.
Why am I lying?
So you guys-
Because you have to go at least 70 to get there.
Why do I have to go at least 70?
Because I was
That's
3
what
hours
AROC
away.
says.
That's the speed over a certain amount of time.
Because 70,
That's how fast you
70
have to go to
times
get there in
3 is
3 hours.
200.
Never went above 65 lbs.
Yeah, how can
I
I,
never went above.
right, I'm saying all right, police officer, got my starting time and got my ending time, and he's saying, you went 70 miles an hour. I was like, no, I only went 65. How can the police officer prove that I went at least 70?
65 times 3 is not 210.
No.
AROC isn't AROC like the change over a period of time, right?
Right.
So then, I don't know, I'm trying to word this. Never mind. Can't get it up.
What is it we're covering today?
The MVT.
What does the MVT say?
That IROC and
That-
AROC have to be the same.
That IROC and AROC have to be the same. So if I've got an AROC that's 70, what has to be true?
Oh, it's 70.
And if there's an IROC somewhere in there, that's 70.
So how does that prove you went 70 miles per hour?
Because he did. Because he
Because-
first drove 210 miles in 3 hours.
This right here is my AROC. Okay?
Oh, so you're saying somewhere in there you had to have.
So I have to be driving in here at least one time. I have to be driving this because the MVT says that if I'm continuous and differentiable, AROC and IROC have to meet up at least once on my interval.
So you're getting a ticket.
Okay? So here's what happens. There are tolls. There are tolls in the U.S. to where when you're driving, there's no exits, there's no on ramps, off ramps. There's stretches of roads where there's no on or off ramps. So what they will do is they'll say, all right, here's where you were at this time, and you get to the other end, and they'll say, this is where you are at this time. Okay? And then they will figure out what? The average rate of change. Okay? And if your average rate of change is higher than the speed limit, what can they guarantee? That you were speeding somewhere along that line.
Can they
And they can ticket you. It will-
What? I didn't know that.
It will hold up.
Good thing there's no tolls on the
It will hold up. It will hold up in court. It will hold up in court.
Good thing there's no tolls on going East Paula because I'd be over every 5 minutes there. I get there in like an hour and a half. That's crazy.
They have machines doing it. They'll have machines that will tag you here and then tag you there and then figure out
No,
their
the
AROC.
tolls can tag you
And they
too.
can
You
figure
have a license
out.
plate, if you have insurance or not. And then they'll send you a ticket for not having
So,
insurance.
so there is there is a practical application for the MVT. Okay, there's how MVT can be used. Notice, let's make sure we've got our two prerequisites. What are our two prerequisites? Continuous, differentiable. Is this thing continuous from 0 to 3 hours? Yes. Is it differentiable? Yes, it's close. Right in here, it's close. I actually drew it a little bit wrong. It shouldn't be on top of itself here. But anyway, you get the idea.
So then, where was your? So that's AROC. Where's your IROC be?
Sorry. Anybody want to come up and draw some IROCs? All right, come up and draw one. You can have more than two. MVT just guarantees what? It happens at least once. It can happen a bunch of times. Okay. Well, go ahead. That's fine.
Oh, it's blue. I need to draw the blue.
Well, I was handing you the red.
Wait, you drew that one up there too.
Just go. If you do that, you're going to have to move this.
Oh.
All right. Now, you don't have to draw it very long. All I need is just
Okay.
Okay, but I agree it happens here. Where else does it happen? It happens up here, and then it happens there one more time. Okay? So at 3 times I was driving exactly 70 miles an hour. At 3 times I was driving exactly 70 miles an hour.
Can they do that too on the tolls? Like pull up?
Yeah, you can fix like
exactly
you
where
can.
it's-
Yeah, you can start and then stop. Like if your parents are driving somewhere and you're not watching, you can say, "All right, we started here, and I'm gonna clock my time when I get to this point," and then you can figure out the average rate of change. You can say, "Mom, I know you were driving at least this fast."
Well, you become a house all the time. She's got a bunch of tickets, so I'm the one.
So wait. So they're saying that at those points you had to go to 70 miles per hour.
At those 3 tangent lines, I was driving exactly 70 miles an hour.
So when the cop says, you're not saying that you were going 70 the whole time.
He's not saying I'm going 70 the whole time. He's saying at least some point you were going 70.
I got
He's going once.
All right.
Well, it's only if you're on the pole.
One more problem.
I'm turning my light go too fast.
I never get on the turnpike. That's wild. Cops are getting smarter. Well, they just make.
All right, I want to do 2 things. I want to do 2 things on this problem. I want to figure out my average rate of change, and then I want to figure out where my instantaneous rate of change is exactly the same as my average rate of change. So I want to do those 2 things. All right. So first of all, can I apply the MVT?
No.
What's the first thing I need to think about?
Is it continuous?
Continuity. Are there any continuity issues with x to the 4th minus 8x? No, because what is not
Doesn't
present?
have a fraction.
No fraction, no radicals, no piecewise. Okay? So we are continuous, so we're good to go. What's my second part?
Differential.
Differentiability. What do I need to look at to talk about that? What? The derivative. I need to look at the derivative. So 4x cubed minus 8. And then I ask myself the same thing. Fractions, radicals, piecewise. Do I have any issues there?
No.
No. So that means I'm continuous and I'm also differentiable. Okay? So that means once I find my average rate of change, I'm guaranteed that the instantaneous rate of change also happens somewhere between 0 and 2. Okay? So what do I need to find next? I need to find my slope, my average rate of change. Okay, so what's that going to look like?
You do like f2 minus f0 over 2 minus 0.
Very good. Okay, so that represents my average rate of change. So f of 2, how do I find f of 2?
You plug 2 into the
Plug 2 in. So 2 to the 4th is 16. 8 times 2 is 16. So that's going to be 0. I plug in 0 and I also get 0 over 2. So that means I get 0. What does 0 represent?
You're still not. You're
AROC.
That represents my AROC. Now the MVT guarantees that somewhere between 0 and 2, what else equals 0? IROC. Where do we get IROC from? The derivative. So I want my derivative to equal what?
0.
0. So what am I going to do?
Substitute.
I'm going to set them equal. Okay? I'm going to set it equal and I'm going to solve for x. And I'm guaranteed to have an x that is between
0.
0 and 2. So I solve this. How do I solve it?
We'll
Add 8. And then, so I get x equals the cube root of 2. Is the cube root of 2 between 0 and 2?
Yeah, it's like 1 something.
Yes, it's probably going to be 1 something. Okay? What happens at this x value? The slope of the tangent line, the IROC, is
equal to AROC.
Equal to AROC, which is 0.
So as long as your value you get from there in between your intervals, it meets up with your AROC.
Yes.
So I don't have to write the there.
So if I plug this in to my IROC, what am I going to get? I'm going to get 0.
So you're saying that x equals that, its slope is 0.
It's slope. Just like we were drawing the secant line and then we were drawing tangent lines, at this x value right here, what's true about this secant line that has this slope and then the tangent lines? They equal each other. Okay, and in this case, they both have slopes of 0. They both have 0 slopes.
So say it was like the square root of, not 4, of 16, and you get 4. So it's not between that, you know it's not going to get up.
Well, I'm guaranteed, because it was continuous and because it was differentiable, I'm guaranteed that there's something that has to work. So if you get something that doesn't work, you don't get any answers that work, then that means you screwed up. Because it has to work. Yes.
But we only have one IROC there. We had like multiple ones in the last one, so.
All the MVT guarantees is it happens at least once.
So.
It can happen more than once, but it guarantees it happens at least
Like
once.
algebraically, we can only get one.
No, you can get more than one. We'll do something where you get more than one.
Okay.